Welcome to today's Explainer. We're jumping straight into some massive AI news today, looking at what is arguably a true step function upgrade for autonomous AI coding agents, GPT-5.3-Codex. If you've been tracking the AI engineering space, you know we've been chasing that holy grail, moving from just a really smart autocomplete to an actual thinking autonomous developer. Well, today, we're unpacking the official docs, the architecture, and the release notes to see exactly how this new model finally merges deep reasoning with absolute frontier coding performance.
Okay, let's dive right into this. Here's our roadmap for today. First, the brain meets keyboard. Then we'll look at why it's faster, smarter, and unstoppable. Cover the cybersecurity capability milestone, peek under the hood at the API specs, go over prompting the new agent, and finally discuss the era of autonomous devs.
All right, part 1, the brain meets keyboard.
So historically, AI coding assistants, well, they were amazing at syntax, right? But they totally lacked deep context. They could write a beautiful, isolated function, but they'd hit a brick wall when you asked them to juggle ambiguous business requirements, write structured docs, and then write the actual code. That's exactly why this statement from OpenAI is turning heads. They're calling GPT-5.3-Codex the most capable agentic coding model to date. And the operative word there is agentic. We're not just talking about spitting out a snippet in your IDE anymore. We're talking about an agent that takes a high-level goal, maps out a plan, uses tools, and just executes across an entire repo without you having to constantly hold its hand.
How they actually pulled this off is pretty fascinating. Look at this fundamental architectural shift. In the past, you had GPT 5.2 Codex, right? Highly optimized for frontier coding, but kind of in its own lane. And then you had the base GPT 5.2 model, which handled general reasoning and professional knowledge. Well, GPT 5.3 Codex takes those two isolated domains and finally mashes them together into a single model. The result? You get a system that doesn't just know how to write perfect syntax, it actually understands the why behind it. Why does this function need to exist? How does it fit into the big picture? What is the user really asking for?
Which brings us to section 2, faster, smarter, and unstoppable.
Now, what's really interesting about this slide is the speed, because once you give an AI the brainpower to reason through massive architectures, it needs the stamina and speed to actually pull it off. GPT 5.3 Codex is running 25% faster than its predecessor. And on top of that, it's way more token efficient. It uses fewer thinking tokens to get the same job done. So if you're out there spinning up long-running workflows or complex automated pipelines, this 25% speed bump literally rewrites the latency and cost equations for your projects.
And this isn't just some theoretical benchmark on paper. This translates to serious extended autonomy in the real world. Get this, during internal testing, this model built 2 entire web-based games completely autonomously over a single extended session. No way, right? It handled millions of tokens without needing a single restart. It also features vastly improved intent inference. That means if you give it a super vague prompt for a website, it actually defaults to building something functional and sensible rather than just handing you a bare-bones HTML scaffold. Oh, and my favorite part, you can now steer it mid-task. You can literally interrupt it, correct its course, and it won't drop the context of what it was doing. A total game changer.
So how is it doing this? Let's talk about compaction. When an AI agent is grinding away for hours, making tool calls, reading terminal outputs, scanning files, that context window fills up incredibly fast. Compaction is this brilliant new feature via the Responses API. Basically, it allows the agent to actively condense its own context window. It holds on to the absolutely crucial prior state and memories and tosses out the noise. This is the magic trick that stops the massive 400,000 token context limit from breaking during those multi-hour reasoning marathons.
Moving right along to Section 3, the cybersecurity capability milestone.
Now, as you could probably guess, with this level of system-wide autonomy, the security implications are profound. GPT 5.3 Codex is officially the very first model to be slapped with a high-capability classification for cybersecurity tasks under OpenAI's preparedness framework. The official docs note it's been directly trained to hunt down software vulnerabilities. Now, to be clear, OpenAI says they don't have definitive proof it can just automate a cyber attack end-to-end all by itself, but its ability to navigate massive code bases gives it unprecedented utility for deep security auditing.
To keep a lid on this, they've rolled out their most comprehensive safety stack yet. We're talking rigorous safety training, automated monitoring, and active threat intelligence pipelines. But the big takeaway for you as a developer is the trust tier gating. You can't just drop in a standard API key and suddenly access all these advanced cybersecurity features. No, those are strictly gated behind trusted access controls. You have to be vetted first.
All right, let's pop the hood. Section 4, Under the Hood, API Specs.
And this brilliantly illustrates the sheer scale we're dealing with here. For all the builders tuning in, check these numbers out. You have a massive 400,000 token context window, and it can blast out a jaw-dropping 128,000 output tokens in a single shot. As for the pricing, it's sitting at $1.75 per 1 million input tokens, and that actually drops to around 18 cents if those inputs are cached, and $14 per million output tokens. Considering this thing can basically act as a persistent engineer on your team, that is a fiercely competitive setup.
But of course, you don't always need it to think that hard. One of the best ways you can manage those costs is with the new reasoning effort settings. You basically get a dial to balance intelligence, cost, and latency. Keep it on low for quick, easy tasks. Medium is your sweet spot for standard interactive coding. But when you have a monster, multi-hour autonomous task, you can crank that dial up to high or even X-high, forcing the model to spend the absolute maximum amount of time thinking before it actually executes anything.
But be warned, those X-high reasoning settings will chew through tokens fast. Looking at the rate limits, Tier 1 gives you 500,000 tokens per minute. Honestly though, if your team is building fully automated pipelines or you plan to abuse that X-high setting, the docs pretty clearly signal that Tier 3 limits, which give you 2 million tokens per minute, are going to be your practical floor. That's where you need to be to really let this agent off the leash without hitting bottlenecks.
Okay, Section 5, Prompting the New Agent.
Now, if you already have a working Codex app, listen up, because you can't just update the model string to 5.3 and call it a day. The whole prompting paradigm has shifted. Here are 3 critical, actionable steps straight from the migration guide. Step 1, ditch the upfront plan prompts. If you force the model to write out a long preamble or plan before it acts, it can literally cause the model to just stop early. Step 2, you have to use OpenAI's exact apply_patch tool implementation. The model was highly trained on that specific diff format, so don't try to reinvent the wheel there. And Step 3, implement the new Responses API phase parameter. This is super important. It categorizes the assistant's outputs as either commentary or final answer. If you drop that metadata when you're reconstructing your history, the docs warn you'll see a huge drop in performance.
You also get to decide the actual vibe of the agent during these long grinds. The guide highlights 2 main pre-built personalities. On one hand, you have the friendly personality. This gives off total human pair programming energy. Lots of narrative, lots of context setting, really great when the task is ambiguous. On the other hand, you have the pragmatic personality. Terse, direct, no fluff. It strips out all the social pleasantries to maximize your actionable info per token. It's totally up to you, so just match the agent's communication style to your specific latency requirements. Which brings us to our final section, the era of autonomous devs.
So, stepping back from the API for a second, we really have to look at the massive operational impact here. So, the crucial point is, this isn't just some shiny tool OpenAI is selling us. It's a tool the creators actually used to build the tool itself. OpenAI explicitly called out that Codex accelerated its own development. Just let that sink in for a second. They put this model to work debugging their internal training runs, managing massive deployment rollouts, diagnosing crazy test results, and handling the raw, brutal operational complexity of ML infrastructure at scale. That is miles beyond code completion, right? That is an AI actively participating in the core engineering lifecycle.
Which leaves us with a pretty wild question to chew on. If an AI can accelerate its own development, debug its own training runs, and autonomously manage the massive complexity of ML infrastructure at scale, what exactly does the future role of the human engineer look like? Are we officially transitioning from writing the code ourselves to simply orchestrating the digital minds that write the code for us? It's a completely fascinating paradigm shift, and the craziest part is you can go explore it in the API today. Thanks so much for hanging out with me for this explainer. Keep learning, keep building, and I will catch you in the next one.